7.3, this is your last thing of notes of the year, which is wild, but this is it, folks. And this is a pretty good section to go out on. If you know your trig stuff by now, it should be pretty straightforward. But we're going to start off with a couple of definitions. Angle of depression and angle of elevation. Angle of depression, here's the definition. So, angle of depression is the angle formed by a horizontal line and the line of sight to an object below the horizontal line. So, kind of a tricky definition, but basically what this is saying is, for example, sometimes you'll see these in terms of like where someone's looking. You'll have someone here's looking, and here's the line, the horizontal line that's parallel to the ground. And let's say they are looking at this flower that I'm not going to draw very well, but you get the idea. There's some little flower there. They are looking at that flower. So their line of vision is maybe not quite like that. That's very, not straight, but their line of vision maybe looks something like this. Okay. So this angle between those two places, that would be the angle of depression. That's what I would call theta. Then you have the angle of elevation. Here's the definition. Angle formed by a horizontal line and the line of sight to an object above the horizontal line. So it's basically the same thing, same idea, just a little bit different in how it's played out. So let's say you have someone here. Here's the horizontal line that's parallel to the ground. And now let's say there's a balloon or something floating up there. Okay, so now this person's looking up at this balloon. And this angle that's looking up now, that is called, that's what we call theta. That'd be your angle of elevation. Think of this depression. When you're sad, you're depressed. Okay, you're feeling down. When you climb into an elevator, sometimes you go down, but the point of the term elevator is that it elevates you, it lifts you up. So angle of elevation will be going up. So for some problems, on example 1, it says, for a reverse bungee ride, Reagan stands halfway between two vertical posts. 2 bungee cords extend from the top of the post to Reagan's waist at a height of 1 meter above the ground. Ah! Scary. How tall are the vertical posts? Okay. So here she is, and she's halfway between them. And we know, because of how these problems work, that I'm probably going to form some right triangle. We're trying to figure out how tall that post is. Okay. Here's the line here, and then here's the horizontal line along the bottom. We know she's halfway between those two places. If this whole distance is 8 meters, that means this part has to be 4 meters. All right? We are trying to find x, okay? So I'm just going to set up a trig function. So if I'm looking at 70 degrees over here, and I want to relate those two sides, if this is my right angle, well, I have my opposite and adjacent side, so that would be tangent. So I'm going to say tangent of 70 degrees equals x over 4. Then to get x by itself, multiply both sides by 4. Feel the pressure to do this before my Apple Pencil dies. So I'm going to type in 4 times tangent of 70 into my calculator. And you should get about 10.9899. That's what x equals. I'm going to go ahead and round that up to 11. So x equals 11. You will notice that this is a meter above the ground. Okay, there you have this additional 1 meter towards the bottom there. So I'm going to say 11 plus 1 to get that total height. So the total height there would be 12 meters. All right. Then Nadim sees the tour bus from the top of the tower to the nearest foot. How far is the bus from the base of the tower? So Nadim is up here somewhere and looking down at the top of the tour bus. So his angle of depression is 23 degrees. That doesn't fill in any of the information in the right triangle, though. This is a trig problem, so there's some right triangle involved. You have your right angle here, okay? And that also means that you also have a right angle up here. So I can actually find this missing angle right here by subtracting 90 minus 23. So if I do 90 minus 23, I should get 67 degrees. And now I can actually set up a trig function, okay? Because we're trying to figure out how far the bus is from the base of the tower, which would be this. I'm trying to find this side. All right? So I know the height of the tower is 180 feet. I'm trying to find that missing side x, and my angle is 67 degrees. If I look at these two sides, 180 and x, that would be my opposite and my adjacent side. So again, I'm going to use tangent. So I have tangent of 67 degrees equals opposite, which would be x, over adjacent, which would be 180. So to get x by itself, I'm just going to multiply both sides by 180. Type that in my calculator. So 180 times tangent of 67, which should give you 424.05-ish equals x. And it does say to round to the nearest foot. So I'm going to say the distance between the bus and the tower is 424 feet. Boom. All right, then on example 2, it says, how can you use trigonometry to find the area of triangle ABC? Ooh, this takes some thinking, all right? So if you look at that triangle, you have your triangle ABC. The opposite sides of each one is labeled ABC, just like we've been talking about. So typically, if you're trying to find the area, as a reminder, that's area equals half the base times the height. You'll notice you don't have a height, okay? However, I can draw one in. So I'm going to say this is H, and here's my right angles formed. So to figure out what H is, I could actually set up a trig function. I'm just going to go ahead and do it. I would normally have you guys really think about this in class, but can't do that. So what I'm going to do is I'm going to say sine of A, the angle in the corner. So if I'm looking at this triangle, my opposite side would be H, my adjacent side would be C. Or not my adjacent side. My opposite side would be H, my hypotenuse would be C. Okay. So then to figure out what H equals, I'm going to multiply both sides by C. That cancels that out. So now I have that H equals C sine A. Now I can rewrite the formula. So I have A equals half the base times C sine A. Okay, I replaced this H with C sine A. And now you have an entirely new formula that you can use that doesn't actually require you to know the height of the triangle, which is wicked cool, and it's very exciting, and I'm sad we can't experience this together in person. So what this does is it gives you a couple different formulas you can use. So for your area, you can have half the base C sine A. You don't need the parentheses like I did before. You can also flip around the letters. You could do half AC sine B, and you could do half AB sine C, depending on what angle you know. The thing you will notice is that the two sides in the angle should all be aligned to one another right in a row. For example, if I look at that first formula, 1/2 BC sine A, here's B, here's angle A, and here's side C. They are all in a row. Okay, so the angle should be between the two sides that you're using. Take a look at letter B. It says in triangle FEG, the lengths of side G and F are 3 and 4 centimeters respectively, and the measure of the included angle is 116 degrees. What is the area? All right, so obviously you have to draw the triangle, else it's going to be confusing. So draw the triangle. I have F, E, G is my triangle. And that also means that the side across from F is little f, here's little g, and here's little e. All right, so I know, I'm going to fill in what I know. Sides G is 3 centimeters, so this is 3 centimeters. F is 4 centimeters. And the measure of the included angle is 116. When it says the included angle, that's just a fancy way to say the angle between sides G and F, okay, besides the two sides that you're given. So this is 116 degrees. And now you'll see that you have information that are all in a row, just like sides CB and angle A were in the previous step that I just showed you. So what is the area? I'm just going to use this formula. So I have area equals half of the two sides, so 3 and 4. You don't even really have to think about what letters is which. And then you do the sine of the included angle, which is 116 degrees. You're going to type that into your calculator. So if I do, you might just do 0.5. So 0.5 times 3 times 4 times sine 116. And you get about 5.39 centimeters. And there's your area.